Hi guys, this is going to be a quick little math lesson. It's day 133. I'm so glad that you get an opportunity to see our faces during distance learning. We wish we could see yours. This is math, so let's get started. Now, today we're going to be talking about what's called a circular protractor. But before we get into today's lesson, make sure you write your first name, last name, circle your homeroom, and get started with your PDN. You can press pause and fill in the information now. All right, guys, welcome back. Our first directions say there are no questions during PDN. We know that. We have to use our own brains because you are genius. Now, for number one, which of the following letters do not have right angles? Let's look at them closely. We know that a right angle is like an L or 7, but it's going straight up and down and straight over. So the first one that caught my eye would be G. I definitely know that G is not a right angle because it has a curve. F has a right angle right here. I'm sorry, T. And so does F, since we're talking about F. And so does E. And Q does not because it is circular. So we know that our answer for number one is Q and G. Number two wants us to fill in the table. Okay, so I've completed my chart. It says say it. Line segment M and E. A line segment has points on each end. One end represents M, the other represents E. Now the way that we write it, you're going to write a little line over M, E, or you can reverse it and write a little line over EM. Now, rays are different. Rays always have an endpoint that begins the way you say it. So ray WX, the W is at the endpoint. The X is the arrow that goes on forever. So the way that we write it is ray over the top with a W and an X. We don't reverse it. We keep it the same way. Flip the page. All right, today's aim is to use a circular protractor to understand a 1-degree angle as 1 over 360 of a turn. So it is a fractional piece. Explore benchmark angles using the protractor. So when we're using a protractor, I wanted to give you guys a visual of what a circular protractor look like, which is why I included it right here. A circular protractor represents 360 degrees. Now, a protractor also has benchmark numbers. All right. The benchmark numbers help us to count to 360 quickly. Now, 1 degree on a circular protractor is represented as the fraction 1 in 360. So it is a fractional piece. Now, when we're constructing a circular protractor, we are going to use 2 circles to create a protractor. When we move the white paper to the left, it shows us our angle. Our first benchmark is going to be 90 degrees. That angle will be a 90-degree angle. We use 4 90-degree angles to make our full circle. So our first turn would be 90 degrees. Copy that, underline that. Our second turn would be, let's see if we can figure it out. If we add 90 degrees plus 90 degrees, what would our second turn be? I'll give you a chance to figure it out. You're right. It would be 180 degrees. Our third turn would be 270 degrees. Our last and final turn would be 360 degrees, creating a circle. Our next benchmark is making 2 turns. Now, when we make 2 turns on a circular protractor, each turn will equal 180 degrees. So, as we move on to the independent practice, I do believe that it should be easy for you to answer the following questions. The questions are, how many 45-degree angles does it take to make a full turn? And how many 30-degree angles does it take to make a full turn? We also have the question, if you didn't have a protractor, how could you reconstruct a quarter of it from 0 degrees to 90 degrees? And lastly, you have to explain how you know which angle shows 90 degrees. All right, guys, make sure you show grit. Watch this video as many times as you can to get the answers correct, and make sure that you submit your exit ticket. Have a great day.